So, hello everyone. In this video, I will be presenting my project titled Cloud Native Processing Pipeline for NDWI Computation using the Docker and AWS Fargate. This project mainly focuses on taking a scientific remote sensing algorithm that is normally run on the local machine and transforming into a fully reproducible and or I can say that scalable cloud workflow using the containerization and the serverless computing. So, what is NDWI? NDWI basically stands for the Normalized Difference Water Index. It is a spectral index used in the remote sensing to detect the water bodies, for example, salt marsh losses or the coastal erosion, sort of that. So it is a spectral index, as I already told, and to detect that they use the green band and the near infrared NIR band. So there is a particular formula for that. Sorry. Yeah, here we can see the formula, that is NDWI green NIR upon green plus NIR. So this is a formula. It is widely used for the flood mappings, water extraction and the environmental analysis. So why I took this project, and I'm going to present my problem statement here. So most of the NDWI workflows today are run on the local computers, which creates several challenges. For example, inconsistent runtime performance, dependency conflicts, lack of scalability, no standardized environment, difficulty in reproducing the results on another system. So, cloud platforms provide a scalable compute, but very few studies test scientific accuracy and when moving NDWI from the local execution to the fully cloud native architectures. So let's talk about a research gap and the research question as well. So my research question is basically, can a cloud native NDWI workflow built using Docker and AWS ECS Fargate that provides the same scientific accuracy as a local NDWI computation while improving the scalability, reproducibility, and operational performance? And if we talk about our research gap, so from reviewing the existing literature, I found a lot of multiple gaps. So some of them are NDWI basically used, and it is a wide thing. Mostly everyone uses that, but almost it runs locally only. The cloud platforms like GE, Google Earth Engine, they process imagery, but they don't allow the environmental control or some sort of scientific reproducibility. And no researchers till now verifies whether NDWI remains scientifically identical when executed on the local Python, Docker, AWS, ECS, Fargate. Yeah. So my research objectives are to implement NDWI locally and establish a scientific baseline, to containerize the NDWI workflow using the Docker for reproducibility, to deploy the NDWI container on the image AWS EC Fargate, and to compare the NDWI results across the environment, to evaluate the performance logs and cloud metrics, and to verify accuracy remains unchanged across all the platforms. So my contribution will be there, like this project is should be a fully reproducible cloud native NDWI batch processing pipeline that produces the identical NDWI outputs in the every environment, and that proves that cloud execution does not change any sort of scientific values, the values which was already discovered using the local platform before in the existing literature, and that should be now even after using the cloud, AWS or any tool like Azure or so now here Let's talk about the architecture overview of it. So, it begins with the total local machine running the NDWI algorithm to generate the baseline scientific value first, and then the Docker engine that should be Dockerized, like the code is containerized to eliminate dependency issues. And then let's move on to the Amazon ECR. So, the container image that is uploaded to the cloud repository, and then the Amazon ECS Fargate, and it executes the NDWI algorithm serverlessly inside a container, so no servers to manage their fully isolated environment. Now let's move on to the cloud. The major thing here is Amazon S3 bucket. So it stores the NDWI output file generated in the cloud. And then finally, Amazon CloudWatch that captures our runtime, the NDWI values, errors, and the system metrics, and makes the cloud execution fully transparent. This is structure, or I should say that this architecture, like I'll show you the architecture here, the cloud architecture, it makes the execution fully transparent. So now I'm gonna demonstrate my implementation for my project. Let's move on to that. Like I'm gonna demonstrate everything I built, my pipeline and all. So in this demonstration, I will implement a cloud native NDWI computation pipeline using the Python, Docker, AWS ECR, and the AWS Fargate. So like there are a lot of things like how I build it, and I'm gonna show you the full implementation of the cloud native NDWI processing pipeline. So basically this includes the running the NDWI algorithm locally, containerizing it using the Docker, uploading the container to the Amazon ECR, running the NDWI computation on AWS Fargate, and viewing the results in the S3 and the CloudWatch, comparing scientific accuracy between the local and the cloud environments. So let's move on to my local environment. I use VS Code. I actually feel very convenient on that to code. So there we go. Here you can see my code to find the scientific accuracy and the runtime. So let's go on to that. I'll run this code. Sorry for that. Yeah, there you go. So here like we can see that I begin my running the NDWI algorithm locally, and this produces our baseline scientific NDWI value, which I will later compare with the Docker and the AWS results to reproducibility. And after running, we can say that my NDWI value, you can see on the screen, that's minus 0.009 something, and my runtime is 0.001 seconds. So now what we are going to do is let's go on to the AWS, and I'm gonna connect my AWS to the EC2 instance, and let's gonna run everything on that. I will gonna dockerize it. So let's go on to that. Take a look at the things I have done in the pipeline I have created to solve the issue. So I have attached an IAM role to my EC2 instance. I can show you that. There you go. You can see that I have created an instance and which is running already, and I have already attached the IAM roles to it. And this allows the EC2 to securely access the AWS services such as the Amazon S3 without storing the access keys there. So using the IAM role is the recommended best option, I believe, for the cloud native scientific workflows, as it improves the security and removes the need to the hardcore credentials. So after that, I have run the test to that my EC2 can access the S3, and after that I have run my code already, which was I showed on the my terminal there, VS Code terminal there, and then my whole the images, everything was there. I pushed to the Docker that I have created in the ECS. I'll show you that as well. There you can see I have created my application there, and with this in the ECR, the image I was creating in the EC2 instance was directly pushed to the ECR, the private repository there, and the output for that will be stored in the Amazon S3. So this is my bucket where everything is stored. The output for that, like the benchmarking thing, the runtime, the throughputs, and everything was there. And I have already put it the everything in the report for that. So that's all. So overall, this project, so let's see that. Overall, this project demonstrates why cloud-native scientific workflows are becoming increasingly importantly, and traditionally NDWI and the other remote sensing algorithms are run on the local machines, but the local execution has limitations. It is slow, not scalable, difficult to reproduce, and heavily dependent on the system configurations as well. So by moving the NDWI computation into a cloud-native pipeline using the Docker and the AWS ECS Fargate, we can gain the several key advantages like the scientific reproducibility, and the scalability and the automation as well, operational visibility as well, performance understanding. We can see that. So there are real world usefulness as well for the flood monitoring, water source management, for the every like the environmental scientists, they need to map the coastal erosions and the Irish salt marsh pops, and the automated GIS pipelines, agriculture water studies. So it allows all the organizations to compute the NTWI repeatedly and the reliability at a scale. So I chose this topic because it connects the three important domains: remote sensing science, the cloud computing there, containerization, and DevOps as well. So this project allowed me to explore how scientific algorithms behave across the different execution and can maintain the numerical bureaucracy. My results clearly show that the cloud native systems can support scientific workloads without losing any correctness. So the final analysis would be the analysis of the results, like the NDWI values were identical across all the local Dockers and the AWS. Runtime might be differed because the container is startup due to the container startup or anything. Cloud provides the monitoring automation. No numerical drift occur in the NDWI computation.